In this last lesson of this unit, we are going to talk about special segments. Those special segments are bisectors and an altitude. And we can use the equations to find missing measures of the angles or of our sides. We already know some of these. We're just going to look at how they apply now to a triangle. So remember a perpendicular bisector. Perpendicular, remember that means to intersect at right angles. And then bisect means to cut in two. And so we can have a perpendicular bisector, which this line right here is a perpendicular bisector. It is a perpendicular bisector because it is going through the side of an angle at a right angle and through the midpoint. So a perpendicular bisector passes through the midpoint. Now there are actually 3 perpendicular bisectors for every triangle. If you look at this, if I kind of eyeball it, we have this. This is not going to go very well, but that's perpendicular there, and that bisects that side. And if I eyeball this one, then that's perpendicular here, and it's bisecting it at a right angle. And one of the things that you notice is that they intersect, and they're always going to do that, but that's a point of concurrency. So that's not necessarily the important stuff, but what I want you to know is that a perpendicular bisector goes through the midpoint of a side at a right angle. An altitude is kind of similar to that, but an altitude goes from the vertex to the opposite side at a right angle. It doesn't necessarily pass through the vertex or through the center of the segment, the midpoint of the segment, but when it does, it's going to create a special triangle we'll talk about in a second. So an altitude is the segment that goes from the vertex to the opposite side. And again, there are multiple altitudes for every one, and again, they intersect in the middle at a point of concurrency. Okay, and altitude is very important because altitude, just like we use altitude when you're talking about the altitude of a plane, the height of a plane, that is the height of our triangle, depending on how that triangle is laid. Then we have our angle bisector. Our angle bisector divides one angle of the triangle, so it starts here at a vertex, and it's going to cut this big angle in half. When it cuts it in half, then it cuts it into 2 equal pieces. And so this line right here is the angle bisector. And just like before, they do cut, every angle has its own angle bisector, and they do intersect all right there in the middle at its point of concurrency. Now, what happens, we talked about the median yesterday. So the median is kind of like the perpendicular bisector. It kind of joins the altitude and the perpendicular bisector together because the median goes to the midpoint. So it goes from the vertex, just a reminder, it goes from the vertex to the midpoint of the opposite side. So this is the median that we talked about before, right? So the median and the altitude kind of look similar. And it's not at a right angle, so it goes to the midpoint like the perpendicular bisector does, but it's not at a right angle. The altitude is the right angle. Now, if you have an isosceles triangle, so remember to have an isosceles triangle, you need to have 2 sides the same. If you have those 2 sides the same, then we know that these 2 base angles are the same. Now, the median goes from the vertex to the midpoint of the opposite side. The perpendicular bisector is perpendicular through the midpoint, and the altitude, which goes from the vertex perpendicular to the opposite side, and the angle bisector are all the same segment. So if you know that the triangle is isosceles, then you know all of those things are going to happen. Or if all of those things happen, then you know that the triangle is isosceles, and that's useful for us later on. So let's talk about altitude and slope. So find the slope of the triangle's altitude through point A. So slope and altitude. So what's important about altitude is altitudes are perpendicular, right angles, perpendicular. So remember when we talked about the slope of right angles, then slope is of perpendicular lines is opposite reciprocals. right? We need it to have opposite signs, positive or negative, and then reciprocal means you flip the fraction over. So we want to go through point A. So let's look at that. We want to go through point A, and we want to be perpendicular. So if we're going to go from point A, that means we're going to drop down here and we're going to hit BC. I want to be perpendicular to BC. So I want the slope of the altitude. So what we need to do is we need to find out the slope of the line that it's going to intersect. So let's pick a couple of points. And actually we can just go all the way from B to C. So let's count the slope from B to C. We'll go all the way from end to end to make sure, because it's kind of hard to see in the middle. So we'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then back 1, 2, 3, 4, 5, 6, 7. So negative 7. So the slope of BC is negative 9 over 7, right? Rise over run. So the slope of BC. So the altitude then is going to have the opposite reciprocal slope. So the altitude then, I can't spell, altitude then is going to have a slope of 7 over 9. Now if I wanted to draw that in, I could do that. So I would, we want to go positive, so I'm going to go down and to the left so that I can have the right direction. So I'm going to go down 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this line right here is the altitude, and we can know that that's perpendicular. So the important part about that is that altitudes hit at 90-degree angles or at right angles, and right angles, perpendicular lines, have opposite reciprocal slopes. Okay, so question 2 is an altitude. Again, that means they're perpendicular, which means 90-degree angles. So all of those things, you got to keep those in mind. So the question is to find GJ. That's what I'm looking for, is how long is GJ? Well, in order to find GJ, I need to find X. So here's what we know. When you look at this, the altitude does not necessarily bisect this. In fact, you can tell by looking at this one, which we don't like to use that reason very often, but this is not an isosceles triangle. These two pieces are not equal to each other. So you have to think about, what other relationship do you know? Well, the other relationship that you know is that JH is the altitude. So JH is perpendicular to GK. Well, if that's the case, then both sides of those are 90-degree angles. They're a linear pair. So that means that 3x plus 3 has to equal 90 degrees. There's your equation. That's what's going to help you to solve for x. So subtract 3 from both sides. You get 3x is equal to 87. And then you want to divide inverse operations. 87 divided by 3. X is 29. Now that doesn't answer the question because I asked for you to find GJ. GJ is x plus 8. X was 29, so we're going to come up here and we're going to substitute in 29 plus 8. And 29 plus 8 is 37. So GJ is 37. So it's a little tricky because I gave you an X on an angle and two sides, but I didn't have enough information about the sides to be able to set up an equation with the sides. So we had to go back to what we knew about the altitude intersecting at a right angle. Okay, so segment AD is an altitude. Again, as soon as you see that word, you need to go in and draw that box right there because it's going to come in handy. So the question is find ADC, find X, find DAC, and find DCA. So let's go and start working on this problem. I see some variables, and so I know I'm going to need an equation. So my equation, what equation do I want to set up? Well, if I look at this, I have to see what all I know. Well, I actually have this big giant triangle. I have this little triangle right here. And then I have this little medium-sized triangle right here. Well, the medium-sized triangle is the only one that has any measurements. And I know from what we learned before that the angles of a triangle add up to 180. So I'm going to come up here and I'm going to say, okay, well then 3x plus 20 plus 2x, this angle plus this angle plus this angle, equals to 180. So now you've got your equation. Combine your like terms. 3x and 2x is 5x. 20 and 90 is 110 equals 180. Subtract 110 from both sides. And you get 70, and then divide both sides by 5, and you get, so we have 5x is equal to 70. Divide by 5, and you get x is 14. So now let's go in and start answering the questions that you were asked. So ADC. ADC is this angle right here. ADC is this angle right here, which we found. ADC is 90 degrees. That's what an altitude is. So ADC is 90 degrees. X was 14. We just found that. DAC. So D to A to C. DAC is this angle right here, which is 3 times x plus 20. So we just found out, so 3 times x, which was 14, plus 20. So 3 times 14 is 42, plus 20 is 62. So that's 62 degrees. And then DCA, start at D, go to C, go to A. DCA is this angle right here, 2x. So 2x, or 2 times x, or 2 times 14, because we found out that x was 14. 2 times x is 28. Now, if you add 90 plus 62 plus 28, you would get 180 degrees, because triangles add up to 180 degrees. Now, let's look at number 4. Number 4, we have this triangle. So you start looking at what you've got. I've got this variable right here that I want to find x. I notice that this is an isosceles triangle. Now, why that is important is because since this is an isosceles triangle, and since this line right here goes through the vertex and is perpendicular to the opposite side, that is an altitude. And when the triangle is isosceles, the altitude and the perpendicular bisector are the same segment. Why that's important is because that means that this piece is 6 and this piece is 6, because it means that that side has been bisected. That's an extremely important concept for us, especially when we get to area later. So now I can take this triangle right here, and I'm not going to use the whole big triangle. I'm going to use the right triangle, because when you have a right triangle, you're most of the time going to use that. So a squared plus b squared is equal to c squared. Now this is a Pythagorean triple, but if you don't see that, it's okay. You can go ahead and keep working it. You'll get there. So x squared plus 36 is equal to 100. Okay, and then finish that out. So you get x squared is equal to 64. Take the square root of both sides, inverse operations. You get that x is equal to 8. Now I mentioned that that is a Pythagorean triple. 6, 8, 10. They have a greatest common factor of 2, which gives us 3, 4, and 5. So that's a 3, 4, 5 multiple. But again, like I said, if you don't remember that, it's okay. You will get it. Okay. Now, word problem. ABC is an isosceles triangle with legs that are 25 and 15. And a 15 centimeter altitude extending from the vertex angle. How long is the base of the triangle? So let's look at what this looks like as a picture. We need to see it in a picture. So we have an isosceles triangle. So we have an isosceles triangle. You can draw any random isosceles triangles with legs that are 25. So I have 25 and 25. Remember that the legs are the pieces that are congruent to each other. And a 15 centimeter altitude. So that means you got to know what an altitude does. So an altitude goes from the top perpendicular to the opposite side, and it is 15. Now it says, what is the base of the triangle? Okay, so the base of the triangle, remember this is what's important, is when you drop down that altitude with an isosceles triangle, it cuts that base in half. So we're going to find half of it. We're going to use this side only because we want to use right triangles whenever possible, because then we can use Pythagorean theorem. So we have a squared plus b squared is equal to c squared. So do the math. X squared plus anywhere you see it, any x squared plus 225 is equal to 625. 15 squared is 225. 25 squared is 625. Subtract those two and you get x squared is equal to 400. Take the square root of both sides, finish that out, do your inverse operations, and you get that x is 20. Now, remember what that means though. That's 20, but we just found half of it. I want to know how long is the base of the triangle. Always go back and do your third read to make sure that you get the whole thing. So the whole base is 40. Okay, we only found half of it because we wanted to use that right triangle. We want to make use of that. Okay, so continuing on with this, solve for x. So when you look at this, I want to solve for x. That means that there has to exist some relationship between this side that has an x and this side that has an x. Okay, now when you look at it, notice what I have marked. I have that these two pieces are equal to each other, and that's a right angle. Now, why that's important is because this goes from the vertex down. That means that this is an altitude. And when the altitude cuts the bottom in half, it automatically makes this an isosceles triangle. That's why that's important. That's isosceles, and that's isosceles. So those two sides are equal to each other. That gives us our setup. So we have 9x minus 30 equals 3x. So we're looking for the x that exists to create that situation. Don't move, usually we move the small x, but in this case, I'm going to leave this 30 where it is, so I'm going to move the 9x. Some of you are going to want to move that 3x over, and then you're going to forget to move the 30 to the other side, but you don't want it set equal to 0. You want x's on one side, and you want your constants on the other side. So we have 30 is equal to negative 6x. Divide both sides by negative 6. And you get that x is equal to 5. That's all I asked for, so you can stop right there. This last one, J and K, is an isosceles triangle. As soon as you know that it's an isosceles triangle, mark your two sides that are congruent. Given JMB, so JMB is right here, and it is 3x minus 15. And KMB, which is this angle right here, is 5x minus 39. And angle K is right here. It's 5x plus 9. Get everything labeled. Find the measure of angle K. All right, so you got to start looking at it, and you got to see everything you know. There's a reason that I told you that it's isosceles. And the reason is because notice that you've got MB, it comes down here. It bisects the sides at a right angle, which makes this isosceles, so I could know that even without telling you. But why that's important is that means that this angle and this angle, JMB and KMB, are equal to each other because MB is also the angle bisector. Now you have a couple of options about how you want to process this. You could say, well, we also know that this is 5x plus 9. So you could say all of the angles added together equal to 180. That's one way to do it. You could take this half of a triangle and say this and this and this, which is 90. You could say those equal 180. Or you could say these two equal each other because the angle is bisected. That's the one I'm going to go with. So 3x minus 15 is equal to 5x minus 39. I'm going to subtract 3x from both sides. And then I'm going to add 39 to both sides. When you go through the math, you end up with x is equal to 12. Now that doesn't answer the question because the question actually said to find the measure of angle K. The measure of angle K is right here, 5 times x plus 9. So it's 5 times x plus 9, which is 69 degrees. So 69 degrees and 69 degrees would be all of these two base angles because they're the same because it's isosceles triangle. So there are a lot of things, a lot of vocabulary words that are important in this unit. And understanding what your bisectors and your altitudes. Altitude is an extremely important word for us as it relates to right triangles because it sets us up to be able to do Pythagorean theorem, which is a very useful tool. Don't forget that when it's isosceles, the median, the perpendicular bisector, the altitude, and the angle bisector all become the same segment. So dealing with isosceles triangles is much easier knowing that.